Hello students, welcome. As a continuation to learn about the identification of organic functional groups, we shall learn about amines and carboxylic acids identification in this session, right? So we are going to look at carboxylic acids first. So in this carboxylic acid session, we are going to look at a litmus test and followed by sodium hydrogen carbonate test, ester test. In the amine section, we are going to look at 5 tests. Carbilamine test is the first one, and followed by mustard oil test, nitrous acid test, Azodi test, and Hinsberg test. Let us look one after another. So the first one is test for carboxylic acid, in which we are going to look at a litmus test. We know that acids will turn blue litmus to red in color, right? So this will be converted into red in color, and this test is given by both aliphatic and aromatic aldehydes. So I have taken aliphatic, and even aromatic acids will also answer this test. But beware, phenols will also give this test. Okay, so the presence of acid should be confirmed with sodium hydrogen carbonate test also. It's a combination. So you need to combine sodium hydrogen carbonate test so as to confirm the presence of carboxylic acid. And we know that in sodium hydrogen carbonate test, we need to take acid and treat it with sodium hydrogen carbonate at room temperature. We will get a sodium salt of this acid along with the water and the carbon dioxide. This carbon dioxide will be evolved as a brisk effervescence, and this brisk effervescence should not be considered as the identification of this acid, but you need to pass this carbon dioxide into lime water, which is nothing but calcium hydroxide, to get milky white calcium carbonate precipitate, right? This is milky white. So after getting the milky white precipitate, we need to confirm that the taken substance should be an acid. Carboxylic acids will react with alcohol in the presence of concentrated sulfuric acid to form esters. Okay, so you will get such ester, and which are characterized by their smell. They have a unique fruity smell from which we can identify that the taken substance must be an acid. Now let us look at the tests for amines. The first one is carbilamine test, right? So when an alkaline solution of chloroform is added with your primary amine, right, we will get a characteristic compound like this one, carbilamine, which is nothing but alkyl isocyanate. Okay, and this compound will have an offensive smell. So from that smell, characteristic smell, we can able to identify that the taken compound must be a primary amine. But both aliphatic and aromatic primary amines will answer this test, and it is a characteristics test for this primary amines. The second test is mustard oil test. It's also known as Hoffman's mustard oil test, and this is also another characteristic test for primary amines. Still, we can able to differentiate secondary amines and tertiary amines, right? When the amines are treated with carbon disulfide in the presence of mercury chloride, okay, I'll get this compound, or N double bond C double bond S, along with the evolution of H2S gas. So we get a pungent mustard oil smell. Secondary amines will react with carbon disulfide to give dithiocarbamic acid, but they fail to smell mustard oil. The reaction will happen, but we don't get a mustard oil smell, whereas tertiary amine will not at all react. So from this, we can able to identify the presence of primary or secondary or tertiary amines. The third test for amines is nitrous acid test. When primary amines are treated with nitrous acid at room temperature, we will get corresponding alcohols, whereas the secondary amines will give you R2N double bond O, a nitroso compound which will look like a yellow oily substance, and tertiary amines will give me salts only. So R3N plus H and NO2. This is a salt I will be getting. So using this reaction, I can able to differentiate primary, secondary, and tertiary amines. The fourth test is Azodi test. This test is given by aromatic primary amines only. So when aromatic amine like aniline is diotized, we will get a benzene diazonium chloride, and which should be coupled with beta naphthol in the alkaline medium at ice cold condition. We get a characteristics orange or red color precipitate, right? And this must be a dye, and that's why the name Azodi test. This will be given by only primary aromatic amines. So the last test is Hinsberg test for prime amines. Okay, using Hinsberg reagent, this is benzene sulfuryl chloride is Hinsberg reagent, using which I can able to differentiate primary, secondary and tertiary amines. So when Hinsberg reagent is made to react with primary amine, this chlorine and this hydrogen will be eliminated as HCl gas, and there is a fusion reaction. Okay, this is a condensation reaction. So this nitrogen will condense with a new bond will form between this nitrogen and sulfur, and this hydrogen will be now acidic. So when I add sodium hydroxide in alkaline solution, this hydrogen will be removed and the substance, the precipitate is soluble. So when I add a base like sodium hydroxide or potassium hydroxide, if the precipitate is soluble, then I can say that it should be a primary amine. In the secondary amine case, I have only one hydrogen which can be removed as HCl when it reacts with benzene sulfuryl chloride, and I don't have any hydrogen, any more hydrogen, right? So it will not react with the sodium hydroxide, but it will react with HCl. In acidic solution it is soluble, but in alkaline solution it is insoluble. Whereas in tertiary amines case, it doesn't have any hydrogen, so that's why no reaction will happen, and no matter what you add, like acid or base, whatever you add, the precipitate will remain as an insoluble one. So using this solubility differentiation, I can able to differentiate primary, secondary and tertiary amines. Okay, which can be better understood by the flow chart what I am going to have here, right? See here, in primary amine, when we add with the benzene sulfuryl chloride in the presence of sodium hydroxide, we will get a clear solution, and if you add concentrated hydrochloric acid, we will get an insoluble mass, and which is an indication that you have taken a primary amine. But in the presence of sodium hydroxide, if you get an insoluble precipitate, right, and it should be secondary or tertiary amine, and that can be differentiated when you add concentrated hydrochloric acid to it. And if you get a precipitate that is soluble, then it should be secondary amine. If again it is insoluble, it should be a tertiary amine. So that's all for today, guys. Thanks for watching. Please do subscribe my channel. Thank you. Happy learning.